All right, so would you mind introducing yourself, please?
Yeah, of course. Hi, everyone. My name is Erica Budina. I'm now a third-year PhD student at the University of Chicago studying molecular engineering, and I'm an alumni of MSEF. I participated in the program from 2010 to 2014. I originally am from Medford High School in Medford, Massachusetts, and my project was on, I did various projects over the course of 4 years, but my projects ranged from chemistry and engineering to bioengineering. And I later pursued bioengineering in undergrad during my studies at Harvard University. And as I mentioned before, I'm now a PhD student in molecular engineering at the University of Chicago, currently working on immunoengineering.
Thank you very much. It was great knowing about you and everything that you're doing. And so as you've said, you've been a dedicated MSEF participant from 2010 to 2014, and which is a great accomplishment. So could you talk a little bit more about your MSEF projects that you started out with?
Yeah, absolutely. So the first project I did was my first year of high school. I didn't have a lot of background in chemistry or material science, but it was something I was really interested in. So the first project I actually worked on was trying to engineer to make a bioplastic, and that's something that I actually did in my kitchen. And the goal of my project was to make a bioplastic and improve its mechanical properties, so its tensile strength. And for my project, I tested different additives, things you could add to the bioplastic to make it stronger. And so this was a great experience because I basically learned about how you could make. I didn't have a lot of materials or access to lab or anything like that, so I tried to research how you could make these materials uh, using low cost materials in a home setting. And I came up with some cool ideas of how we could make them stronger. And it was a great experience because I learned about the scientific method, how you go about coming up with a question to ask, how you go about trying to address that question, and then also figuring out ways to collect measurements and test your question using the resources that you had. So in my case, I didn't have a lot of access to, traditional equipment. So I figured out a way to basically develop an equipment from home that I could use to measure the tensile strength of the biomaterials. So that was the first project I did, and it got me really enthusiastic about science, really enthusiastic about research. So the having the opportunity to participate in MSEF allowed me to connect with different students and scientists and kind of learn what it's like to do science in higher education, in academia, industry, all things that I wasn't super familiar with before I had participated in the program. And the last 2 years of high school, I was really fortunate to have the opportunity to do a summer internship at Tufts University, which was where close by to the town that I was, Bedford. And I was really fortunate to be able to transition from making materials in my kitchen to being able to design materials in a laboratory setting. And this was also a great experience because I had the opportunity to expose myself to the interface of material science and biological applications, tissue engineering, which opened up this whole new world for me. And so my later projects focused on how we could make a material that could allow us to culture cardiac cells, heart cells on the surface, and how different parameters like how the material is and the composition of the material, how these two parameters could impact the phenotype or behavior of cells culturing on them. So these projects, as I said, really inspired me, and having the opportunity to pursue these projects in a laboratory setting really inspired me and made me want to pursue bioengineering in college. And that was a great starting point for me. And in college, I was able to use the experience that I had garnered in high school, and through participating in these programs, to be able to do more research. And later, it helped get involved in another branch of bioengineering, focused on understanding how we can design materials for modulating the immune system. And that's actually what I currently work on right now in my PhD studies, like trying to engineer technologies for controlling the immune system. So I hope that answers your question.
That sounds so cool and really impressive and really, really interesting. Thanks so much for sharing that with us.
Absolutely.
That's so cool. And so to further that, how did you get from those MSEF projects to where you are now? Maybe a little bit more about your undergraduate experience and getting your PhD and all those experiences you had.
Absolutely. So my undergrad, I studied bioengineering, and the reason I studied this actually stemmed a lot from some research that I did in high school. I was really interested in the intersection of material science and biology. And I felt at the time, and I still do, of course, that bioengineering really well captured this interface of interests, like allowed me to classes in biology, but also in other subjects that I was interested in too, like chemistry and math. And I was able to combine these interests, these many interests together in my research. In my undergrad, I joined a lab, the Mooney Lab at Harvard University, which designs materials for different biological applications. But the application that I was working on was trying to design a material that could help us control the behavior of different immune cells. So we were interested in learning about how the surface and the composition of a material could impact the phenotype of a type of immune cell called dendritic cells, which are important for for modulating the immune system. So how did my studies kind of, I think the way I got interested in this was a combination of the research that I had done in the past with the coursework I was taking in my undergrad, really kind of these interests together. And I was able to pursue this research. And I think kind of every lab experience you do kind of helps you learn about a different topic, and it helps you kind of figure out closer and closer to what you're interested in doing. So in my undergrad, I was doing a lot of material science work and a lot of immunology work. And for my PhD, to pursue this aspect, this immunology, this idea of trying to better deliver drugs and medicine and molecules for the application of modulating the immune system. So I did a lot of research when I was applying to PhD programs. I was interested in pursuing research further. So that kind of motivated me to apply for a PhD program, which basically involves taking coursework for a few years and then devoting a lot of time to doing independent research. So the main goal of doing a PhD is you want to basically answer a question, work towards answering a question that no one has ever answered before. And at the conclusion of your PhD, you come up and the findings of your research, which is supposed to be kind of this, approach for answering a question that people hadn't figured out the answer to. So I was really interested in this, and I kind of figured that out through all the research experiences I had, through my desire to learn more to pursue a topic in a great deal of depth, and through all the time I had spent working in a wet lab, I knew I was really interested in that. So When it came down to picking the topic I was interested in and picking the PhD program I was interested in, I really wanted to combine my engineering background with also this interest that I had in immunology that I kind of learned about through my research, through working in these research labs. And that kind of got me to the molecular engineering program at University of Chicago, which is a relatively new program that integrates immunology, bioengineering, tissue engineering. A lot of researchers, investigators in our department focus on trying to come up with new ways to deliver medicine that can have applications in modulating the immune system. So the thing I work on now is trying to use a technique called protein engineering to try to figure out a way to deliver these proteins called cytokines that can actually help to suppress the immune system. And we use these proteins in diseases. We want to use these proteins for as medicines for diseases called autoimmune diseases, where the body's immune system is not working, and where we want to basically quell the excessive inflammation. So the goal of my research now is to try to figure out a way to these proteins such that we can deliver them, better deliver them to the right places in the body, and to help people with autoimmune diseases.
Thank you very much for sharing that. That was a really interesting journey. And I think the protein engineering, everything sounds really cool. And that I think that inspires me very much. And I wish you the best of luck with your work. And, you know, as you were saying, I kind of thought about how your first project with MSEF was working with bioplastics. And I've heard people at Biogen speak about how they're doing the same thing, and it involves like a whole lot of trials. And you started out as a high schooler learning how to work with what you have with something as big as bioplastics. And you must have learned a lot from those experiences from MSEF to fast forward to now where you're a PhD student, and as you've said, worked in a lot of labs and things like that. So I was wondering, has there ever been a moment in your life where you've realized that something that you learned from MSEF has helped you in your educational pathway or your career?
Yeah, absolutely. I think MSEF was really played a huge impact in me learning about scientific method. And I think that as you move further forward in your career as a scientist, you have to apply the scientific method many, many times. And I think, you know, the first place where, you know, for doing my science fair project for the first time, that's where I learned about the scientific method. So no matter how many projects you do, how complex the projects get, I think the essence of all of this work that we do really hinges upon the scientific method and applying it well. So the first step in the whole process was learning about this method. Like what is the objective of your work? Like what is the motivation of your work? What is the objective? What is the hypothesis? What kind of methods are you going to use to be able to try to answer this question? What kind of results that from these methods? And then, you know, how can those results, how can your experiment be improved? How can you do this next time? That whole process is extremely important. And the first place I was able to learn it and apply it was my project with MSEF. So I think even though the work that I do now is quite different from the bio that I made the first time, we're still applying the scientific method. And having the opportunity to learn that at a young age, I think really helped me a lot. Another thing that was really important to learn early on was the fact that sometimes things don't always your hypotheses aren't always right. Sometimes things don't work out, and there's a lot of trial and error involved in science. Like sometimes your work, and you have to redesign your experiment or improve your design to be able to get better results. And that's something that I learned also for the time working on my science fair project at MSEF. Like I remember the first iteration of my plastic design. The first time I did it, the very first time, the bioplastics didn't even gel properly, and I had that thought. I was like, well, so why isn't this working? And then I had to do more research, and I found out, oh, I need to adjust the concentration of one of these chemicals that I'm using, one of these additives that I'm using. And then the next time, when I made them again, I realized that they were just better. So this whole aspect of trial and error, this whole aspect of having many iterations to your project, I think is critical for doing good science. And it was great to have the opportunity to learn that so young through a science fair project.
That's great to hear, and thanks for telling us all about how you've used the scientific method and trial and error in your jobs, because I know a lot of scientists do that, and it's a really important part. Um,
Absolutely. And I think one last thing to add is that I know that in science, a lot of the times, people like what you read about is the end result of a project. But there's so much time and so much effort. A lot of the time and effort is spent doing things like optimizing your experimental design, and so it's really a super important part of doing the science.
awesome, thank you. And so maybe could you talk about what's your favorite thing now about your job, or what position you're in now? What's your favorite thing?
Absolutely. So I really love being a PhD student. I love, having the opportunity to ask questions that haven't been asked before. I love the aspect of doing new science and learn new things every day. That's my favorite part of my job. I love reading papers and designing experiments and um, analyzing data. Those are things that I first learned about when I was doing my MSEF project that I still love doing. And I think that's one of the reasons I decided to do a PhD. Something else that I really love that I have the opportunity to do as a PhD student is also be able to mentor undergrad and high school students. That's something that I really love doing. One thing I didn't mention that I should have mentioned even earlier in the interview was that when I did this internship in high school, I had a really great mentor. She was a postdoctoral scholar in the lab I worked in Tufts University, and she was really a role model for me. She really took so much time to help me learn and help me get interested in science and help make me passionate about science. And having really had a wonderful role model early on in my career, it makes me really motivated to also pay it forward and hopefully help and mentor other students, so that they also have hopefully great experiences with science early on. So another aspect of the job that I it's been a little more challenging during COVID, of course, but I really, I love having the opportunity to mentor other students, high school students, college students. That's something that I enjoy doing in the lab and also through other programs in the PhD, other outreach programs in the PhD program, and also another thing that I do as part of my PhD is I also uh, act as a teaching assistant for courses. So I also really enjoy doing that. So for me, like my favorite aspects of the PhD are both the new science that I get to do every day, and then also mentorship and helping other scientists learn. And also another thing I really love is the opportunity to collaborate with other scientists. I think one thing that's really important that um, you also see in collaborative projects, some people in MSEF, I remember together on projects, is that science is not done by one person. It is a huge endeavor. It involves many people working together. kind of putting bricks wall to try to answer big questions. And so another aspect of the job that I really love is having the opportunity to work in a collaborative laboratory setting where I get to talk and work with people who are experts in things that uh, I'm not. So it's wonderful having the opportunity to kind of work with people who have skill sets that you don't have, and putting your skills together to be able to answer big questions. Um,
Definitely. Thank you so much for talking about that. And as you've said, for as an aspiring researcher myself, all of that was very inspiring. And I do know that when it comes to research, there are a lot of challenges involved, especially in a complex field like material science and immunology. So could you talk about some of the challenges that you've overcome in your educational pathway?
of course, I think, there's a lot of challenges that people can encounter, especially working in STEM, women in STEM. I think, it is indeed a challenging field, and I hope, I think one of my goals is I hope that in the future I can act as a mentor and as a support system for future students. Um, for me, one challenge I did have was when I transitioned from high school to college. In high school, didn't really struggle a lot with any of my classes. I got really good grades and I did really well. And I ended up getting a full ride to Harvard, which was a huge, personal goal for me. And, definitely a transition going from being, in a public school with many, many students to going to a very challenging, intense university program. And there were a lot of times in college when I asked myself, like, am I good enough? Like, can I be successful in this field? But I was very fortunate to have had a lot of mentors and role models in college, a great support system in college that, helped me. I think, of course, it was definitely a challenge, transitioning from, high school to college. Obviously, the classes were harder. There was, you know, uh, a really there was it was quite competitive, but having this support system, having through my research and through my coursework, I was able to um, meet great mentors and students that helped motivate me and helped me realize that this is a field that I'm really passionate about, and it's a field that I really wanted to pursue in college and also beyond that. But I do think that um, sometimes some students can feel discouraged um, in science because there's a lot of emphasis on getting the right answer. And so some students might feel like, oh, well, I didn't get like a perfect grade in math, or I didn't, get the highest grade in science. So does that mean I'm not a good scientist? And I would say absolutely not. Like there's so many aspects of becoming a great scientist. One of course, is, learning the material and doing well, doing your best academically. But there's so many other aspects, like creativity is very important, hard work is very important, perseverance is very important. And I think that it's very important for us to make people aware of that, so that when people do struggle, they understand that it's okay to struggle because it's part of the learning process. Um, and when you learn, and when you do um, you know learn the material that you're struggling with and become better at it, there's this huge sense of gratification and joy that comes from that. And and so I hope that people understand, you don't come into college or come into high school being good at something. Like you have to work hard, and it's about what you learn, not how much you know. And it's about how passionate you are about something, and and what you feel like you can give to a field. not just, how fast you can solve a math problem or, things like that. So I hope people really, that's something that I learned in college, and I hope that others can understand that too.
Wow, that's great and really inspiring to hear. And I'm sure that a lot of the viewers of this video will really appreciate learning about that, as many are current juniors and seniors applying to colleges. So, in that same vein, do you have any advice for the college application process in that stage of your life?
Absolutely. So I think I would just, one thing that I would say in retrospect is don't stress out about it too much. Really hard to say that because I remember stressing out a lot about it when I was a junior and senior in high school. But as someone who has been in school for quite a while, I would say that, of course, applying to college and getting into a good program is important, but it's not the only thing. There's really it's only the beginning. I would say, getting into college, the beginning, and then there's a lot of other things that go on after that. So I would say the first thing is, don't stress out too much. Um, One thing that really helped me with application process was, when I was applying to colleges is, you know, being able to talk about, what I was really interested in, what I was really passionate about, what I wanted to do with the college application that I would be getting if I got into these schools. So having the opportunity to do science fair early on, it really was one of the first times where I realized, like, hey, I think I want to be a scientist. And having the opportunity to participate in that program early on also helped me with the college application process, because I was able to talk about something that I was really passionate about, like becoming a researcher. And then also I was able to describe something I had done, which is a science fair, that showed that helped me demonstrate my interest. So I think when you work on the application process, it's really great to talk what you're interested in. And of course, this can change many, many times, both in high school and in college. But think being able to kind of think about what you're really interested in, what you're passionate about, and how what are some things you've done to create that interest, and so what are some things you want to do in college with that interest. um, of course, we are living in very challenging times, and with COVID, with the pandemic, it's of course really hard to be able um, to expose yourself to different programs and different things outside of the classroom. So it is of course much more challenging now than it must have been for me. But I think being able to advantage of any opportunities you can to really explore some things you might be interested in, I think that can really help with the college application process. I think also I think maybe when I took the SATs, it was quite a while ago, but there is also an emphasis on standardized tests. Um, so I would say, taking advantage of any, prep program, practicing as much as you can for the exams, studying as much as you can for the exams, taking advantage of any kind of program your school offers to be able to practice as much as you can before taking the exams. Of course, there's a lot of discussion nowadays on, you know, how important are these exams? What do they reveal of a student? So I would say, try your best with the exams and take advantage of any opportunities that you have to be able to study and prepare as much as you can. But if you don't get the score that you aim to, just be aware that this is not the only thing that matters when applying to college. Of course, taking coursework is really important in high school. So just trying to take the right balance of challenging courses, AP courses, and also regular courses, trying to figure out the right balance that's good for you. You don't want to overwhelm yourself too much. You don't take every single class, just AP class, just because it's there. Like, really try to think about what you're interested in, how much you can handle, and try your best in these classes, because they're really a good window to what college classes are like. Having the chance to take these AP classes is really helpful because kind of kind of help you prepare for college classes, try to, help you prepare for, what it's like to be in college. You can get some exposure to that through your courses. Um, and, I think the best advice I have in terms of applying for college is really just try to be as authentic as you can. Like use the essay, the opportunity where I think there's opportunities to write essays and talk about what you're interested in. Like just try your best to present yourself in the most authentic way possible. Don't try to tell them what they want to hear. Try to tell them who you are as a person and what you want to do. And of course, be aware that that might change. And it's actually good, to change your mind. Like there's nothing wrong with that. And but just, um, try to tell them about what you're passionate about at the moment and how you can use the education that you will gain through their program to achieve your goal. I think that's what they're really looking for. Like in my college essay, I actually talked about, the experience. The first one of my essays talked about, the whole process of doing the science fair for the first time and how that made me want to be a scientist. And I think trying to use experiences that you've had to illustrate what you want to do in college, in your career, I think really important and really valuable and can help set you apart from other applicants. So I would say, try your best and just, be aware that, no matter what happens, even if you don't get into, the undergrad program of your dreams, like it's not, that's the, it's not the end, it's only the beginning. So when you're in college, you're going to have the opportunity to study and learn and explore what you're interested in even more depth. And when you're in college, I would say, work really hard in your classes. Don't be afraid to take risks and, explore, take classes in things that are new to you. Don't be afraid to do that because it's really a great opportunity to explore things that you otherwise would never be, wouldn't have been able to explore before. And, a lot of universities are also great research institutions. And I think, I was very fortunate as an undergrad. I had a lot of opportunities to part in research and really learn in undergrad, like is research something I'm interested in? So I would say like when you're in college, definitely try to take advantage of as many, internships, research opportunities as you can. Don't just limit yourself to your college, university, to just your university. Also try to apply to programs that are, outside of your school, outside of your comfort zone, because I think every opportunity, every internship, every opportunity that you have, that you do in college really help to inform your career in the future. So I hope that helps. But if there's any other questions, any other things you want me to touch upon with this question, feel free to ask.
Definitely. Thank you so much for that. I think that might have been very helpful for a lot of the people watching, especially because you talked about standardized testing and you touched upon how people can further expand on their interest on research. All of that was really cool. And I noticed that you talked about finding your passion even more so for science when you were applying to college and wanting to be involved in research. And I guess I want to ask you, was there a specific moment in your life that made you want to be a researcher and be in the fields that you are currently in right now?
Yeah, absolutely. So I think there were a lot of moments. Like I think early on when I was doing these projects, very young, like in ninth grade or 10th grade, as I said before, like it was really the first time that I ever had the chance to do science. And I just remember the feeling of it being so new and so exciting and being something that I really was looking forward to every single day. And I think that's something that has stayed with me even now. Like I'm still so excited every day to go into work and try something new. And that's kind of this sense of joy that is still with me, and that I remember feeling early on when I was doing these projects. So just, you know, it wasn't even, I had the chance to do many projects, but that sense of excitement, I think, for doing the science and designing the experiments was something that I learned for the first time early on when I was doing these projects, and something that has stayed with me. Another aspect of things I love is, have the opportunity to present your work and sort of um, tell a story. When I was younger, like even before high school, I thought I wanted to be a writer. And it turns out that, I didn't pursue that, but I think there's this aspect of writing, there's this aspect of storytelling involved in doing science, of course, nonfiction work, but that is really important. It's being able to take your results and present them and share them with other people in a way that they can be understood by a mass audience. And that was something that I learned about in science fair for the first time. I remember walking the exhibit hall, seeing all these students and all these scientists, and it just brought me so much excitement and joy being able to tell my story in a way that made sense. So I think so there for me, what I love about science fair was, of course, being able to do the project and kind of go through the scientific method. That whole process kind of made me realize that I'm really passionate about science and I love doing science. And that's something that I still really look forward to every day when I work is, being able to do cool science in lab every day and come up with design experiments and work towards executing those experiments. But another aspect of science that I love, that I was first exposed to in science fair, was having the opportunity to analyze your findings and present your data and your project in a way that can be understood by many people. I think one of the most important aspects of science is being able to disseminate scientific information and explain it to not just people who are experts in your field, but also people who don't know anything about your field. And one of the most exciting moments, maybe one of the most nerve-wracking moments too, I remember was being that moment, walking into the exhibit hall of MSEF, and then also I remember it was at MIT, like this really wonderful institution, and also like when I had the go to ISEF, walking into this exhibit hall, getting the chance to meet students from all across the state, and also scientists and judges and people who were walking by that were just interested in the project. And one of my favorite aspects of the whole process was being able to kind of tell the story and explain my findings and my results to others. That's something that I think is really essential for doing good science, is figuring out results mean and how can you explain them to other people. And the first time I had the chance to really do that was when I did my science fair project. And that's something that I have to do a lot now at work, and in my PhD is figuring out ways to understand my results and share them with other people, people both in my lab who are very familiar with the work that I do, and then other people who in the university who do kinds of research, or people in the scientific community that do other kinds of research, or the general public, trying to explain science and have it make sense, I think is super important. And that's something that you learn a lot about in science fair. So of course I'm really grateful for the opportunity to have both been able to learn the scientific process for the first time in science fair, and then also how the process of presenting your work and sharing your work with others. I think those are two super critical things I had the chance to learn for the first time that are still very important for the work that I do in my PhD and beyond.
Definitely. Thank you so much for speaking about that. And I'm really glad to see your passion for MSEF and the science fair. I think it's very inspiring for a lot of people watching.
Yeah.
Yeah. And if there's anything else I could say, I think, the most important, maybe you guys hear this a lot, but I think the most important thing is sort of the process by which you go about things. It's not really so much your end result. Like, I think a lot of people think about, okay, my experiment worked or it didn't work, but I think, the most important aspect of the project and, a science fair project, and then also, doing science is not just what happens in the end, but kind of how you go about it, what you've learned from doing this experiment, and how you can do it better next time. And that's something that I learned about in science fair that I think holds true in real life as well. And that's something that we're learning even in the public, like learning about these vaccines, like with the pandemic. We're learning that people, we have these really cool vaccines now. We have these variants. We might need to go back and improve the vaccines to be able to protect us against these new variants. And there's this really important iterative aspect of science that is really critical to learn about early on, that I think science fair helps us learn really well from young age.
That's awesome. And I was just wondering, could you talk more about what's it like to work in immunology during the time of COVID?
Yeah, so it's definitely an interesting time. So for me, the first year of PhD happened midway through COVID. So my first 6 months of PhD, I moved to a new city. I moved to Chicago. I had spent the rest of my whole life before moving here was in East Coast in Massachusetts. So I made this big move to Chicago, and in summer of 2019, I joined my lab. So that was at the very beginning of PhD, and the first 6 months I spent taking more college classes in grad school, and then January, February. Before the pandemic was when I was first started working on my project in the lab. And the focus of my project was in developing molecules for trying to deliver molecules, improve the delivery of molecules for autoimmune diseases. And then in March of 2020, the pandemic began, and it was quite a crazy time, because things were constantly changing. At the beginning we didn't even know, like, we didn't really understand this disease well. We didn't know how it spread. And so there was a lot of changes that were happening. And, one of the main changes that happened, at the university level was the university shut down. So at the beginning, all classes went on Zoom, as of course happened with you guys as well. But something that I'm really proud of, that I had the opportunity to participate in, was that so our labs shut down, and our labs being an immunology and engineering lab, we had the opportunity to reopen early in the pandemic, so April 2020, and we weren't working. We stopped working on our projects, our individual projects, but we had the opportunity as a lab to come together and work on these two collaborative projects. This was before the vaccines came out, so started working on these collaborative COVID-19 related projects. Specifically, we were interested in trying to develop an early stage vaccine. Obviously, this was not at all related to the vaccines that came out through industry, but having the chance to basically work on these collaborative COVID related projects with the whole lab was a really wonderful experience for me as a new grad student, because it really shows that science is a collaborative process. It's your individual work is not as important as the work that you do together with other people. And I think this pandemic was very unfortunate, but having the opportunity to work on these collaborative projects, these very meaningful and timely projects related to infectious disease was, a really important and great experience for me. And so we had a chance to work on these collaborative projects for several months while everything was shut down. And then, things slowly started to reopen, in the summer of 2020. So, you know, after spending, 4 or 5 months working on these collaborative projects, I had the opportunity to then go back to working on my initial projects in the lab. But so even though this wasn't, a long-term project, it's definitely, it was a very impactful project, I think, for me in my PhD, because, it helped me learn even more, the importance and value of collaborating with others on kind of prioritizing, projects that are timely and important. And I think because of that, despite, the struggles of of trying science during COVID, I think I became a better scientist because of it. And, learned, to work even more closely with other people. And yeah, that was the experience that I had. And now things are a little bit better, kind of going hopefully back to normal, but it was definitely an interesting experience starting a PhD during these crazy times.
Wow, that's so cool and really interesting that you got to work on those collaborative projects surrounding COVID. That's really interesting.
Definitely. All of that sounds very cool, and it's cool that you got into this field and you saw firsthand how important all of this was. So,
Yeah,
um,
absolutely. And
yeah,
I think one thing I really learned was that, even though, these mRNA vaccines are just coming out, right now, some people might say, oh, this is the first time that they're being, used in people. But, there has been, years and decades of research that has been happening in the laboratory setting to get these vaccines to where they are. And I one thing I learned about, as we were working on COVID related work was that, this work, wasn't started from scratch. This was work that people built upon brick by brick for many, many years. And it's gratifying, even when you learn about this science, to know that, this is the work, the byproduct of so many people's hard work and efforts. So it makes you feel great, even more grateful that, so many people work so hard on these vaccines to get them where they are right now.
That's really cool. Thank you so much for speaking about that.
definitely. And thank you so much for doing the work that you do. We were
Yes.
like elated hearing about all of this. It was a really great experience getting to meet you today.